Hello, everyone. Good afternoon. My name is Morgan Garland. I'm the Operations Manager with WESIS, and today we have Gloria with us from Ford Motor Company, who's going to be leading our webinar. Before we get started, I wanted to give a little introduction to the organization for those of you who are not familiar with us. We often go by our acronym WESIS, as in We Sisters, because that is exactly what we are. We are a global cyber sisterhood. We are a 501c3 nonprofit organization with a global reach dedicated to bringing together women in cybersecurity from academia, research, and industry to share knowledge, experience, networking, and mentoring. We have over 10,000 members in 95 countries with 70 plus professional affiliates, 270 student chapters, and that's just our community alone. We offer a variety of different initiatives and programming efforts throughout the year to all of our members. One being our webinar series. We have our online member community portal. We have our mentor-mentee program, speakers bureau, our leadership series. We have virtual and in-person career fairs, and so much more. We owe all of our initiatives to our wonderful strategic partners, our tier 1 partners being Akamai, Amazon, Level Blue, Bloomberg, Carnegie Mellon University Software Engineering Institute, Cisco, Ford, bringing us our webinar today, Google, Lockheed Martin, Microsoft, Optum, Cynthia National Labs, and Sentinel One. Just a reminder, if you have questions, please ask away today. There is a question box on your screen that you'll see. You can drop in questions throughout the presentation. We'll save those till the end. And then subscribe to the WESIS newsletter if you haven't already. That way you can stay up to date with all of our upcoming programs and initiatives and all great things WESIS. With that, I'm going to turn it over to Gloria to get started and kick off our webinar today.
Thank you. Hey, hi. I'm Gloria, otherwise known as the antenna lady at Ford, because I actually put radio frequency antennas on cars. Let me share the screen, make sure this all works well, Rosalie. The question is, did that work?
That worked. We see your screen.
Did that work?
Yep.
Oh, yay. Okay. So there's an airplane on this presentation. I did a presentation at SAE Aerotech, something similar to this. I co-chair SAE G32, which is CyberPhysical Systems with Bill Schofield at Boeing. On the left-hand side, you see a book, Cybersecurity for Commercial Vehicles, that I wrote in 2019. And then I just wrote another book called Cybersecurity for Entrepreneurs in 2023. Now, why is that interesting? How did I get from airplanes to commercial vehicles to cars to EVs? In 2019, I did a book signing on this book, this Cybersecurity for Commercial Vehicles. There were 2 chapters in that book that launched into G32. One was called Engineering for Vehicle Cybersecurity. The people whose name on here are actually PhDs out of the aerospace world. Dan DeMasi is still very much in G32, along with Zach Collier, who I also wrote the next book with, and Braun Pav, who's actually leading up the hardware section of G32. And then we have Chapter 10. Chapter 10 was written by the Department of Energy, and I like the title, How the Truck Turned Your Television Off and Stole Your Money, Cybersecurity Threats from the Grid. And that stemmed off of some work. I typically would review Department of Energy papers for advanced technology for vehicles, and that stemmed out of a paper that they had written there as well. So we morphed that. I promised my friend Lizak that I'd help solve this problem on EV charging, so I'm going to show you what we put together there. So what is G32 and what's its point? So the goal is to develop standards that characterize and address the risk to cyber physical security, and really looking at weaknesses and vulnerabilities and coming up with recommendations. The goal is to go across all industrial verticals. So aircraft, engines, cars, trucks, commercial vehicles, tier 1, tier 2 suppliers. We have water involved. We have infrastructure involved. And so I met Bill Schofield actually about in 2015 when I was looking for best practices for cybersecurity for commercial vehicles. So Bill's actually co-chairing that. And Joel works for Dan DeMasi, and he helps keep everything together. So what standards have we progressed so far? We have JA7496 that was published in June 2022. We have a software assurance publication coming out hopefully by the end of the year, along with hardware. And I'll talk a little bit more about hardware as we go into the next slide. So what's the difference of cyber physical security compared to just regular cybersecurity? So the definition here is your cybersecurity measures are taken to protect a computer or computer system against unauthorized access or attack. But what is a CPS, as we're calling it? You've got new cyber risks coming from threats to exploit weaknesses and vulnerabilities. And you'll find I love to break systems, so I love to find the weaknesses and vulnerabilities in systems. But now you've got integration of complex hardware, software, and firmware. And some people say firmware is hardware. Some people say firmware is software. So that morphs back and forth. And these vulnerabilities drive establishment of the area of cyber physical systems security. So I'm going to give you this perspective only because it goes with the next slide. So in my world of putting antennas on cars so that cars can communicate through telecommunication or through Wi-Fi, we have to deal with how things connect. And so you're going to start to see where I start looking at EMC mitigation, particularly on vehicles. But I'm putting these words out here. So when you see the next slide that's animated, you'll understand what it is. So a cyber physical system means physical or engineered systems whose networking and technology functions and physical and virtual elements are deeply integrated. And so they're connected to the physical world through sensors, actuators, or other means to enable safe and effective real-time performance in safety critical and other essential applications. And so actually, as part of that, we actually get involved in talking to sensor experts about the weaknesses of sensors, whether they're smart or they're not smart, and how they connect. And to put it all simply, all cyber physical systems contain brains powered and controlled by electronic parts and hardware with embedded software and firmware. You're going to see that in the slide as well, how things start to tie together. CPS, cyber physical systems, they're connected in a physical world, whereas CPS sensors are connected to the physical world through electromagnetic spectrum. And both the physical and electromagnetic environments are naturally occurring. The electronic operating environment is human-made, and you're going to see the humans show up on this slide. Humans interface with the CPS technology for defined purposes related to the CPS design functions. That is a lot of words. Let me show you an animation. There's the CPS. Because we're going across everything. You're looking at sea, land, air, and space. Cyber physical system. There's the electromagnetic operating environment we were talking about. Here's the electronic operating environment, EOE. And this is how you start to have people start to interact. Okay, hopefully that makes sense. I'm going to go to the next slide. So let's look at this from perspective. So cyber physical systems combine the cyber and physical world, and they respond in real time to their environment. So they include electronic parts, assemblies, systems, system elements that operate as a single self-contained device or with an interconnected network. An added distinction is a requirement affecting a tangible output through command and control electronics. I'm going to go to the next piece. Examples of this are wearable medical devices, smart grid, autonomous vehicles, supervisor control or SCADA systems, industrial controls, IoT systems, satellite communication systems for commercial and government integration, and embedded systems. So you're going to start to see this. All of a sudden, the hardware shows up. See the piece of hardware showing up? And this is how that hardware, which ends up being very integral across all these systems, becomes very important. So what G32 is actually working on is the sublayers of boards that actually had come out of some military work and actually is backing from DOD and the Pentagon to help solve the problem in terms of what's going on with board work. Okay, that was a lot. I'm going to make this a lot simpler. So now what are we looking at? Now we have a cyber physical system. We have hardware, software, electronic data, your firmware. And obviously, I look at things from program all the way down. So I look at things from schedule, capacity, cost, technical scope. Obviously, electronics tie into that. You always see me into architectural diagrams. And then, of course, your security foundation. I'm leaving this just as another concept. This is actually a good chunk of what G32 is about, which is what we call domains of consideration. There's 14 of them actually in G32. They came out of initially an IEEE paper, and then that actually ended up in my book, and now we've refined this, and now this is G32. So I'm just going to use the word domains of consideration. We'll talk about it in this next video, but there's 14 of them, and they're rather detailed. So I just want to put that out there as a concept. So now what do we have as an EV charging system? I'm just going to show you one car that's going into a charging system, and I'm not going to do the many cars in the charging system, which is another complex system. But why did we pick EV charging systems as an illustrative example? One, because I promised my friend Lee, and this is before I showed up at Ford, that I would go help solve the problem, because you're going to start to see it's very, very complicated as to who touches EV charging. There's going to be more proliferation in sight. You'll find out, I'm always the advocate saying, you know, what type of cybersecurity is sitting in your charging systems currently. The stations are highly dependent on how they interface with the vehicle in the world. There's electronic sophistication going on. I'm the one who keeps saying, DOE, can you give these guys more money to make sure they're secure when you're designing these? And a security engineering plan is required that's agnostic to hardware, software, electronic data, and functional purpose and properties. Something that we did with SAE, it's taken us probably about 6 years to get to where we are so far in our standards. When you read standards, if you've been involved in standard work, you always want to go fast, but it's very difficult to go fast. And I think standards are really difficult to read. So we actually convinced SAE that we would take an illustrative example, which is EV charging. Again, something you can talk about. You cannot talk about a lot of DoD systems, but I can talk about an EV charger. Can an EV charger be similar to something else? Yes. Has someone taken our EV charger example and applied it to UAVs? Yes, they have. So we've started here the technical process framework, which is how you're going to document things. You have a risk management framework, and then you have domains consideration framework. And what I'm going to show you on a video really just starts with the technical process. I've done some real basics for you on G32. I've taken this video and crunched it down to a 17-minute video, and that's what I'm going to show you. So we're focusing on the red circle. So I'm going to flip over to a video. Hopefully it lets me do that. It's not.
With the context out of the way, let's get into the illustrative example. The focus of the illustrative example is a fictitious company Y, which is intent on delivering electric vehicle charging systems to a customer. Historically, charging systems were analog, and cybersecurity threats were neither concerns nor did they even require consideration. However, modern solutions are digital and are comprised of reprogrammable computing equipment that are part of a logically networked system versus a physically connected system. These components are selected and integrated to manage the high voltage and current needed to replenish the charging levels of power storage within the electric vehicle, or EV. We will show how the technical processes allow us to begin identifying and considering security risks and plan for remediations and mitigations early in the design process. As stated, JA7496 defines the 14 technical processes. They are depicted as the required technical processes in the middle of this slide. The standard is consistent with IEC 15288 and the NIST Special Publication 800-160 overlay of 15288 for software security. The technical processes define a set of activities that are specific to securing cyber-physical systems, or CPS. However, they do not define a strict engineering process or a technical procedure. Each process defines an activity. Those activities can be tailored iteratively throughout the CPS lifecycle. Each version of a CPS product shall have an engineering plan that describes how each required technical process is executed and documented. For new product development, the technical processes begin with the business or mission analysis, abbreviated on this slide as 1 business analysis, and concluding with disposal. The ordering communicates the historical general flow, but they can be transformed into the development or acquisition concepts shown. For example, the left side of this diagram compares waterfall and agile methodologies. Both need to involve the same technical activities of scoping, designing, developing, testing, validation, operations, support, and sustainment. However, the waterfall will define high-level activities of system scoping and design in the beginning, and then incrementally step through development, testing, and integration, while the agile method will take a working product and iteratively architect, design, develop, test, and integrate additional solutions into operations without a known final product in mind. Despite these differences, the same technical processes will be applied while allowing each organization to follow its own methodology. A similar comparison exists for new product development. Traditional product development starts with an idea, early concept research and design, and then, following a critical design review, will develop, test, and analyze market landscape before introducing the product. Emerging processes for CPS are adopting Agile and DevOps principles, in which product ecosystems are developed iteratively while responding to feedback from customers. All the technical processes are still required, but again can fit within these different methods. This slide shows an example of adjusting and adopting the technical processes for a product introduction pipeline. The 5 blue arrows at the bottom indicate our EV charging company's milestones for new product introduction. The numbers in the bubbles are intended to show the relationship between the required technical processes and the notional milestones for the fictional company. The initial milestone might be a value screen for our EV charging services, as in this case. Certain activities associated with the business or mission analysis technical process might apply here. For example, we might start by identifying the CPS security environment, characterizing and establishing high-level CPS security needs and initial objectives of the EV charging system. This constitutes a business-level operations view. This view provides a foundation for other activities that include defining and characterizing the CPS security threats, vulnerabilities, and weaknesses that, if compromised, could have adverse consequence or result in an unacceptable level of risk to business objectives. This view could identify where we would need to connect, where we would do business, what aspects of the charging station we could buy versus what aspects we might need to develop, and so forth. Many of these business feasibility decisions at this stage might be focused on cost and time to market in order to make a quick business decision. At the value screen milestone, the organization's requirements to move fast may mean that not all the required technical processes will be covered at this point, because they will be considered at a future organizational development stage. This illustrates that while all the technical processes are required, they are intended to fit iteratively into the organization's engineering framework. Once the value screen is approved, then the second milestone might be a feasibility and business plan. A more complete business view is required that refines and manages the CPS security risks. For the illustrative example, risks at this level might include the use of third-party billing systems and various types of connections to energy management technologies and the electric grid. Here, we could complete remaining activities of a business and mission analysis technical process, including identifying high-level activities and information flows. Furthermore, this feasibility and business plan could also include activities from other technical process, such as identifying and documenting stakeholder CPS security needs, constraints, and assumptions, translating integrated stakeholder CPSS needs into system-level CPS security and assurance requirements throughout the CPS lifecycle, and identifying product or service providers who comply with 7496 or equivalent standards. Whereas the value screen only completed a subset of activities from the technical process business and mission analysis marked as 1 on this slide, an organization might combine activities from business or mission analysis, stakeholder needs and requirements definition, and system-level requirements definition marked as 1, 2, and 3 on this slide. with the intent of completing all required activities associated with those technical processes and collecting information to inform risk management activities. This is an example of where we see value from the defined technical processes. They enable us to create a larger perspective of the interconnectedness of the CPS and the multiple stakeholders involved. They ensure that our feasibility and business plan milestone is appropriately accounting for the security implications and artifacts. The next slide will illustrate this further. Ensure you consider the stakeholder and interconnections of the charging system on the illustration coming up next. This illustration shows data flows between systems operated by different stakeholders under CPS normal operating conditions. The customer, Company X, procures electric vehicles and requires safe and effective on-site charging stations and services from Company Y. Recall that for the illustrative example, the EV charge services operator, or Company Y, is the fictitious company delivering this charging service that requires CPS security. As the primary service provider, Company Y has developed and provides a charge operations backend service, smartphone app called Charge App, and integrates with a third-party charge management server and charging station called eCharge. The Charge App is also designed to integrate with another third-party billing service. The service is integrated with the local utility backend through an aggregator and meter data service, which is connected to a national energy grid. Company Y can also arrange the option to connect a distributed energy resource near the end user. A color-coded table is included to link the equipment/service to stakeholders and their primary digital electronic interaction paths. This is illustrated with the row labels on the left column and the interaction groups on the right column. This subcommittee has categorized the stakeholders from the provider's, meaning Company Y's, point of view. On this table, we can see that Company Y, listed in row A, is the primary developer, integrator, operator of the EV charging services. They contract with a business listed in row B for charging stations and integrate with other capabilities listed in the other rows. Company X, in row C, is the customer who procures charge services to enable their drivers to use the stations. Multiple third parties also develop and provide components and services to make the chargers safely and effectively accomplish their design purpose. For the purposes of this example, the two CPSs are the electric vehicle and charging station. The CPS support systems, or CSS, are the smartphone and app, charge management server, and EVCS backend service. CPS support systems are off-board systems designed to support CPS on-board functions. It is critical in the SAE standard to acknowledge the interdependence that a CPS has on items of national interest. We have also numbered key notional data flows within the illustration. This is an orientation slide and is limited to only high-level data flows to illustrate expected operating conditions. The data flows form an ecosystem which cross trust and security boundaries between various stakeholders represented by the black dashed lines in this slide. The data flow diagram is useful as it captures digital paths that may have impacts to mission, safety, financial, organizational, or to the national interest. It illustrates the normal operating condition of a CPS functioning in an expected or planned operating environment. This operating condition view informs risk management frames in later videos, as well as risk decisions. During the feasibility and business plan process, the fictitious organization will not complete each of the three technical processes individually, but instead will augment their engineering procedure to ensure that it addresses the union of activities required across all three processes. The consolidation of CPS security activities across these three technical processes results in an 8-step procedure that we can add to our list of artifacts required for the feasibility and business plan milestone. This emphasizes the need to adjust and tailor the process to the business operation and procedure and not the other way around. As we combine these, we can see a process of developing a system view, using the system view to develop risk scenarios. Prioritizing those scenarios and then identifying remediations or mitigations assures risks remain manageable through an iterative and traceable risk management process. As we continue with this activity, we see additional integrations of the required technical processes into the design, development, and initial product stages. For this illustrative example, the design milestone of the organization might require the integration of architecture, as seen in the operating condition context diagram, design, and system analysis of CS security activities. For this process, the application of technical processes could look very much like a threat model that results in a risk management baseline. This analysis defines and predetermines the scope and development of the test plan. Activities from across technical processes may include developing an initial architecture approach and architecture level assurance requirements, developing an initial CPS security design approach, system elements, and system level CPSS assurance requirements, updating system element level CPSS functional and non-functional requirements, or establishing analysis and evaluation plans at the system and subsystem levels. Performing trade-off analysis, options analysis, and assurance requirements to mitigate prioritized vulnerabilities, and producing software, hardware, and data artifacts. As we enter the develop milestone, the previous technical processes should have laid the foundation for assuring the delivery of a secure system, capable of fulfilling its purpose under defined operating conditions. The organization might require the design milestone to include the subsystem implementation and integration processes 7 and 8, where technical changes are developed to address any identified threats and/or vulnerabilities. This would include activities such as identifying and considering vulnerabilities that could be introduced because of integration or interfaces that involve people and organizations who up until this point did not have access to the CPS or its security plans. Identifying and prioritizing classes of vulnerabilities that need to be addressed throughout the develop milestone. Managing and controlling flows of the supply chain for critical and essential components. Determining how to verify and produce evidence that CPSS meets security requirements. Defining operational procedures and limitations to achieve CPS security requirements. For Process 14, initial disposal activities might include wiping the system and deleting sensitive information, debugging interfaces and accounts, testing keys, passwords, and test artifacts prior to disposal, intellectual property loss procedures, and developing mechanisms that prevent reverse engineering of sensitive elements. For this illustrative example, the charging system is developed iteratively under increasingly more representative operating conditions. As development progresses, security verification, validation, and transition processes are conducted. If adverse findings occur, the project schedule may be delayed while addressing those issues. The development cycle continues until the CPS is ready for transition. Before final transition, a development team steps through the disposal technical process to remove debugging interfaces and other backdoors. Delivery and operations during initial fielding might require close coordination with qualified maintenance personnel and/or providing a feedback channel for customers. This engagement may be necessary because unauthorized maintenance or subsystem modifications might lead to a security compromise. Activities could include identification, analysis, and assessment of countermeasure options that would provide a basis for development recommendations. Furthermore, customers will need to understand that a breach could look like and how to monitor and/or respond to indicators of a compromise. For example, if improper maintenance procedures occurred or the charging station was repaired by an unauthorized service, then the charging station may be left in an insecure or unsafe state, resulting in revisiting activities in Process 7 and 8. Security activities need to be tailored to fit into business needs and reduce adverse impacts. These activities include developing the organization's prevention and incident response plan, vulnerability management plan, and vulnerability disclosure policy and procedures, and configuration management. These activities must be continuous throughout the lifecycle until obsolescence results in the final disposal of the system. Updating assurance cases, acceptable levels of risk, and criticality analysis metrics within safety critical, mission essential, network essential, and non-essential groups will be discussed in Part 2. As the product matures and enters final operational configuration, supportability and sustainment will likely also change from the initial delivery configuration. The operating condition and interface architecture, external to the CPS security and trust boundary, and use case may be different from the system that is evaluated during the development milestone. Activities could include analyzing operations to identify and evaluate triggers for reinitiating the CPSS engineering process and identifying what data should be collected for monitoring, prevention, and event detection, and how it should be communicated, analyzed, and preserved. During the CPS operational lifecycle, The CPS operating condition, use, and configuration may change enough to require an updated risk assessment. In the jargon of the standard, result in a triggering event that could trigger activities from technical processes. Customer reuse, alternative interfaces, product modification, field reports, additional security research, and so forth may identify additional risks, threats, or vulnerabilities not considered in the initial development processes. Maintenance and operations activities will follow prevention and incident response plan, identify triggering events, and assess impact severity. If more preparatory work for managing risks is done up front, then the less expensive the sustainment of CPS security will be throughout the lifecycle. This emphasizes the value of a continuous risk management framework that is central to the CPS security and each technical process. To review key points in Part 1. Throughout the EV charging system, we showed how the required technical processes may be adjusted and/or grouped depending on the stages or milestones of the system design. We showed how they may not necessarily be sequential and have disparate security objectives that are relatable to the milestone objectives. Finally, we showed how the technical processes may be applied at every milestone to reduce the costs associated with mitigating threats later in the system, and how these processes can be iteratively applied throughout the product lifecycle to inform risk management processes. This concludes Part 1 of the illustrative example focused on introducing the technical processes for cyber-physical system security as it applies to electric vehicle charging. The risk management framework is the topic of the next video.
Ta-da! A lot to throw at everybody. But what we did with SAE is we have two videos that are actually for free. We call it Video 0 and Video 1, and that was part of Video 1. And that's just to explain to you what G32 is and how you can start to use it. So, Rosalie, am I supposed to go in and look at questions here?
Yeah, I can also help. So we had two that I'm going to send your way. So however you want to handle this. One, somebody wanted to ask how they are able to connect with you.
Best thing is find me on LinkedIn. So I'm Gloria D'Anna. You'll find like an artificial intelligence cover and then a picture of me out in Iceland. So it looks sort of adventurous. So that's me.
Perfect. And then another one was how, if they wanted to learn more, any resources or tools that you recommend.
Oh, well, start here. If you want like book one, a little thick. Actually, there's one of these, I believe in the Ford Cybersecurity Office, but this is more like a textbook. And it really looks at Class 7 and 8 trucks, but also goes down to medium duty trucks. But probably one of my favorite topics in here, I try to write this like Freakonomics. So try to take fun topics and make them interesting. I always recommend don't read it all at once. But the first one was actually written by Doug Britton, and he used to run red teams for the government. And he wrote a chapter called "Should We Be Paranoid?" And I always say within 8,000 words, you will be. So this is a good place to start. And also, you probably saw during COVID how important trucks were. And, now everybody has delivery trucks, coming to their door every day. And obviously Ford sells a lot of those vehicles as well. But it basically says, it's from the American Trucking Association, and it really tells you about the importance of trucks on the U.S. economy. So that's that. If you want something funner, this is funner. I wrote book 2. Actually wrote this with, we'll do another chapter on this, but I actually wrote this with a lot of my friends from G32, and this is much more fun. So maybe the next topic will be how cybersecurity is like suntan lotion. So this is Peter the salesman. He showed up in an IEEE paper years ago explaining cyber-physical systems, and now he's an entrepreneur and used to always have a bad cyber day, and I almost killed him off. But my co-writer Zach said, "Don't do it," and he came back, and he's going to go into a next book and be more successful. And anyway, those are good places to start.
Wonderful. And then there are a couple questions, so I'm going to read them to you. One is, are there many women in your type of role? And if not, how would you recommend us getting into that type of work? Because it looks very interesting.
Well, this is very interesting. Actually, in my book, when I started doing cybersecurity, probably back in 2017, I was running into more women actually in cybersecurity than in anything else. And I've been in the industry a long time, and I would go into a room of 200 people in a conference room and be the only woman. So if I was running these cybersecurity meetings, and there are actually a lot of women there, and it's because they were smart and they were put on something that was difficult, and everybody's like, go figure it out. And the women actually showed up in that. So actually in cybersecurity, I've run into more women than I typically have run into in any other parts of engineering. So keep going. And I do encourage that. I encourage everybody to get excited about cybersecurity.
Wonderful. Next question is, which cybersecurity certifications would you recommend for aspiring cybersecurity analysts?
It depends upon what you want to do. It can be all over the board. If you are a student, there are two things I really would recommend. They're not certificates, but there is a hacking seminar for automotive types, and there's a hacking seminar now for commercial vehicles. If you get into those, they've been growing since they started maybe 5-6 years ago. And you'll be coached by some of the best hackers in the business in the vehicle world. And you'll be busting your butt for a week, actually, and learn a lot. And everything's very confidential as to what comes out of there. So if you're an aspiring student, get yourself into one of those. It's intense. And I'd say you're being taught by some of the best out there in auto and truck world.
Next question is, do you see this standard being useful for DERs?
Let me say what the standard is. How do I say it? It's very broad reaching. Okay. The goal is not to replace what's out there. The goal is to create something that's very holistic. Okay. So the goal is not to compete with some very good standards that are out there. Okay. Whether it's DoD or automotive or truck or aerospace. That's not the goal. So the thing is, I want people to think about things in a very, very large perspective. And things are going to get more complicated, and things are going to get worse. And your cybersecurity attack surface is going to get worse. And I live in the RF world. I live in the things that can't be seen world. And the interactions in radio frequency and EMC mitigations are huge. And people don't see them, or they don't explain it. And they don't understand it. So I try to take those concepts and explain things to people as to what really happens. I'll give you an example. I work with a bunch of really smart people. And these are people who like logarithmic scales, okay, in their graphs. They really love that stuff a lot. And so they'll throw all this data at you, and it's like, that's really nice, but you got to explain it to the mechanical engineer. How are you going to do that? And then they go through all this, and I'm like, the Rorschach presentation was really nice, but they don't get it. What do you have? Do you have an apple? And so we did this one presentation that was Apple. I said, apples are good. And it was red. I had it be red. And then I showed it that if you take a bite out of the apple, it's bad. Well, they got that. So you got to take some really difficult concepts, make them really simple so people understand what decisions they need to make. So if that helps.
Wonderful. Another one is to know a little bit more about your career and journey and background, if you want to share that.
Oh, my resume is very long.
You want to pull out some of your favorite highlights?
Some of my favorite highlights. I started out at Kettering U as an engineer. I then won a scholarship to go to business school. GM as a GM fellow. I then landed at Ford in product development because I caught the product development bug actually at the University of Chicago, which was a precursor to the entrepreneurial program. I then have worked for just about everybody. So it used to be that you weren't allowed to go through silos. And so I have a expertise in finance and marketing and engineering, and I love systems and I love new tech. And somewhere in all of that, so I've done cars, I've done trucks, I've worked for every OEM, I've worked for every tier one just about. But then I had an opportunity to run into a government telecommunications expert. And so he took me under his wing for about a decade, and I learned an awful lot about satellites and communication. And what I really see is everything is really about communication. Everything's really about your cell phone. I mean, think about your whole life that's on your cell phone. Mine's got Wonder Woman on the back. But so everything really comes down to telecommunication. And then I really got into EV charging systems because I saw that as, where we're going with EVs. And I love a systems approach, but I'm also really good at breaking things. So never give me a prototype. But things will just get worse. And you've got to come up with a way to solve that problem. It's very, very hard to defend. It's easier to hack. So you've got to think about things broader. And how do you teach people to do that?
Wonderful. And then another question was, how do you integrate your work at Ford with other organizations like SAE?
Well, it's very interesting. So I was able to, I took I basically said RF. Well, this is great. First of all, I work on components that don't have software in them. We're passive antennas, which is great. So I actually don't have to apply exactly 21434 to my component, which is great on purpose, actually, although it connects to other things. And because I do communication off a vehicle because of antennas, I learn everything that's related to a vehicle. It's very, very fun. And I live on the upper part of a vehicle development cycle. So I live in pre-planning and pre-PS and that type of thing. And then SAE basically allows me to use my leadership skills. So we've got about 200 to 300 engineers. These are like cyber experts. Oh my God, these people are just brilliant. The guy who actually, the Canadian who actually did that video is actually a cyber warfare expert. And so he looks at things very holistically. Obviously, you'll see the satellites, national interest. We talk about power grids, et cetera. They're just fascinating people to talk to. And then as you start seeing new things that will happen with tech, this group is already in the middle of it. Why? Because they're the PhDs in that tech space. They see the risks that are coming up. So I don't know if that quite answers it, but it's a very exciting piece. And it dovetails to what I do because I keep seeing more and more pieces that you can affect.
Wonderful. And then another question is, are there opportunities for subcontractor consulting with Ford or employment opportunities? Where should they be looking?
That's not my space, but go to Ford.com and there's always job openings.
Perfect. That's all the questions in here that I'm able to see. So anything else you'd like to share before we end the talk?
Get involved. Cybersecurity is an exciting space. It's going to continue to get worse, not to do, the sky is falling, but be very proactive out there. Look at things holistically, help educate people. That's what I do in a fun way, I hope. And go up to SAE, find the G32 website, go look at video 0 and 1. They're free. If you are part of SAE, you can then get into what we just are published as video 2 that start to look at risk. If you have friends who are not super techie, but they like finance and they like risk, and even if they have a law degree, that stuff starts to play into how do you put risk around what's going on with your cybersecurity, what's affordable, what makes sense. So lots of places to play.
Wonderful. And actually, one more question came in, so I'm going to read it. They see on the SAE's website that there are many documents listed as a work in progress for G32. Is there an opportunity for other SMEs to become more involved in this process?
Absolutely. Contact me.
Perfect.
Absolutely. In fact, we just added Canadian government people onto the panel. A lot of our power from the U.S. comes from Canada. I live near the border, so obviously that's really important for me. I'm back and forth to Canada all the time. But yeah, absolutely. I recruit all the time, believe it or not. I recruit off of LinkedIn to have people come in, and it is a brilliant group of people. Brilliant.
Wonderful. There are just more questions coming in, so if you don't mind, we still have time. I'm going to keep reading them.
Sure.
What do you think about cybersecurity and autonomous vehicles?
Well, that's sort of a broad question. I will answer this from a aerospace standpoint, if that helps. So I happen to be able to moderate women in AI. In fact, all the PhDs, top PhDs in aerospace. And they specifically looked at AI and autonomous. Well, first of all, they didn't think airplanes were really going to be autonomous, okay? But they looked at AI and cybersecurity and how do you make airplanes safe, okay? So everything about an airplane is how to make it safe. You really don't want airplanes to fall out of the sky. So with that mission statement, cybersecurity is very important to them, right? And then when you look at autonomous, they're basically saying you're really going to have autonomous, people talk about having autonomous, taxis in the air. They don't see that really happening, but they do say, how do I take AI so that not that they're going to be autonomous, but how that can really help make things safer. So I don't know if I answered that exactly, but I think you have to define what you mean by autonomous, or we really talk about level 5, when you answer those questions.
And next question is, how do you recommend learning about and training in ICS cyber?
Google it. Again, what do you really want to learn? Okay, so that's a broad question, but what do you really want to learn? What really excites you? So I actually got to go to the State University of New York at Albany and participate in a hackathon with them. And some of the stuff was really boring. I said, this is really nice, but I want to know what really excites you. What part of what you're doing is really, really interesting, and tell me about it. And then we sort of graded them, and whoever won the hackathon actually had a much better answer to that. But you can say ICS, well, what's that really mean to you? I mean, what is it that you really want to solve? And so therefore, what do you really want to learn? So I hate those broad questions. So sorry about that. Go in, go learn a little bit more and go, oh, well, what really bothers me? I like water. I like my water to be clean. I'm now like experts with the cybersecurity water group. Okay, that's exciting. I happen to like my power a lot. I spend time talking to guys who do sensors. You always want to have a discussion on how to break things, but what can you do to make sensors better, right? So what bothers you? And what do you really want to work on? So don't do broadly like that. What does that mean? You want a job doing that? What do you want? What do you want to really do?
I love it. There are no more questions. Gloria, thank you so much for your time today, and we very much appreciated it and everything, and I hope everyone has a great rest of their day.
Thanks. Thanks so much. Bye-bye.